Okay, let's unpack this. We're getting into the pretty specialized world of AV protection today.
We really are.
I mean, if you're putting an expensive PTZ camera outdoors for sports, for monitoring, anything really,
Yeah.
your biggest problem isn't the picture quality.
No, not at all. It's stopping a total environmental failure.
Exactly. So today we're doing a deep dive into the Datavideo D2-HEAT-POE camera housing.
A piece of gear designed to let you put a high-end PTZ camera pretty much anywhere and, trust that it's going to survive.
Right. So our mission is to break down the engineering here. How does this thing justify its cost? It claims to protect against impact, theft, the elements.
The warps.
Let's start with the shell, the housing itself. It's designed for their Pro line, right?
Yeah.
PTC 150, PTC 280.
And the newer 300 and 305 series, yeah. It's made from a thermoplastic polycarbonate.
Which is an interesting choice. You often see metal alloys for industrial gear. Why go with this?
Well, that choice is very intentional. It hits two main threats. First, impact resistance. Polycarbonate is just incredibly tough. But second, and maybe more important, is thermal regulation. Metal can transfer heat and cold really fast, which just makes condensation inside a nightmare. This plastic is a much better insulator.
It keeps the internal environment more stable.
Precisely.
Okay, so beyond the material, the specs mention an IP68 rating. What does that actually mean for someone installing this on, say, a stadium roof?
It's a huge deal. It means the entire system is sealed, totally protected from dust getting in, and it can handle being completely submerged in water for a long time.
But the really interesting part.
The really interesting part is that this rating applies to the connection ports, too. And crucially, it's rated against saltwater air ingress.
Ah, salt air, the silent killer of electronics on the coast.
It is. That corrosive mist just eats away at circuit boards and solder joints. An unprotected camera might last 2, maybe 3 years. This housing is like a long-term life insurance policy for the camera inside.
So it keeps the outside world out. But what about the climate inside the dome? That brings us to the heat PA part of the name. It has a heater blower.
It does, to prevent any condensation from ever forming on the lens or the electronics.
But how do you power that? Especially in a remote spot where running another electrical line would be a massive headache.
And that's the core innovation. It's all powered by PoE.
Power over Ethernet.
Yes. The single Ethernet cable that you're already running for the camera's data feed also powers the camera, and it runs the internal heater. One cable does everything.
So you run one line up to a pole or the roof of a building, and you're done. That simplifies the logistics immensely.
Absolutely. We're not just talking about saving one wire. You're cutting down installation time from a full day, maybe to just a few hours.
Okay, let's put this into a commercial context. The housing itself, part number D2-HEAT-POE, is listed at $975.
Right, just for the protective shell.
And you're putting it on a camera, like for instance the Datavideo PTC 280 NDI 4K model, which runs about $1,799.
So you're adding almost $1,000 of protection to an already high-value asset. It's a serious investment in reliability.
So this deep dive really shows that the D2-HEAT-POE is this comprehensive all-in-one solution. You get extreme impact resistance, that critical IP68 protection, and then the seamless PoE-powered climate control.
It forces any operator to really calculate their true tolerance for risk.
Which brings us to our final thought for you. When you consider the high price of these compatible cameras, how does spending nearly another $1,000 on protection change the financial equation for you? When you're installing gear in these hostile environments, what level of risk, from weather, from vandalism, from theft, is truly unacceptable?